Imagine an atom as a tiny, incredibly dense pea. At the center of this pea is a nucleus, and even smaller particles fly around it. Ordinary bombs explode because chemical substances burn quickly. A nuclear bomb works differently. It uses the energy hidden inside the atom itself. There are two main ways an atom can release a lot of energy. The first is nuclear fission, or splitting. Imagine a very large fat atom, for example, an atom of uranium isotope or plutonium. These atoms are unstable. If a tiny particle, a neutron, hits such an atom, it becomes so unstable that it splits into two parts. When an atom splits, a huge amount of energy is released. This is the explosion. New, smaller atoms are formed, and most importantly, new neutrons are released. These new neutrons, in turn, collide with other atoms, causing them to split too. This is called a chain reaction. It happens instantaneously. One atom splits, releases neutrons. They split more atoms. Those release even more neutrons, and so on, exponentially. In fractions of a second, billions of atoms split, releasing colossal energy. In a nuclear bomb, it's essential to have a sufficient amount of uranium or plutonium. This is called critical mass, and for this mass to be rapidly and tightly brought together. This is achieved using conventional explosives. They compress the fissionable material to ensure the chain reaction starts and doesn't stop too early. The second way is nuclear fusion, or a thermonuclear bomb. This is an even more powerful type. Instead of splitting large atoms, here, very light atoms, most often hydrogen isotopes, deuterium and tritium, are combined to form a heavier atom, for example, helium. The problem is that to force light atoms to fuse, very high temperatures and immense pressure are needed. Where do you get such temperatures? Inside a conventional nuclear bomb. So, a thermonuclear bomb is essentially a bomb within a bomb. First, a small nuclear fission bomb explodes. This mini explosion creates incredible temperatures, millions of degrees like on the sun, and pressure. At this temperature, hydrogen atoms begin to fuse, releasing far more energy than fission. This is the thermonuclear explosion. In both cases, the result is a colossal release of energy, manifested as a massive blast wave, thermal radiation, an instant, blinding heat capable of causing severe burns and fires over vast distances, and radiation, dangerous particles and emissions that can cause radiation sickness and contaminate the area for a long time. This is, in simple terms, how one of humanity's most powerful and destructive inventions works.